Good morning, everyone. How are you guys doing today? How's everyone doing today? Good morning, guys. Can you hear me? I hope everyone is doing well and you're busy preparing for the exams. And any questions before we start? Is there anything you want us to focus on today? Or you want me to explain? Is there anything that you want us to focus on? Or do you have any questions? Okay, if you guys don't have any questions, we will continue with our chemistry revision today. And we started yesterday and we did some examples. And I started with this slide to show you guys which examples of strong acids, strong base, and an example of weak acids and weak bases. And we did a calculation of the pH from a given solution, and we also did the titration question, which was A, but we didn't solve for B. So I will say to everyone, you can take a picture, you can write it down. B, I want you guys to try it to see if you use the titration equation, you calculate the mass of the base in this question. The answer you're supposed to get, it's supposed to be the mass equal to 0.03 grams. And if you don't get the correct answer, you can let me know and I can see your workings and I can guide you from there. So this is a little homework or a practice question for you guys. So that it says 35 centimeter cubed of hydrochloric acid with a concentration of 0.01 mole per dm cubed neutralizes 50 centimeter cubed of the BaOH2 solution. Calculate the mass of BaOH2 in the 50 centimeter cubed solution. So with what you're given, you can be able to calculate for the mass. But I'm giving you this as a little homework, and if you don't get the mass, feel free to let me know in the WhatsApp that ma'am, I didn't get the answer, where did I go wrong, and I'll be able to guide you from there. Are we together, guys? Did you take a picture? Did you write it down? Can we move on to the next examples or revision? Okay, so let's start with this example today. I've already written it down because I want to cover more examples today. And the first example says calculate the pH of each of the following solutions. Remember the pH we've calculated before. We're given, sometimes you had to write your balanced chemical equation and you had to find out. So this one, it says a solution with the concentration of H3O plus, it is equal to 1.45 times 10 to the power negative 4 mole per dm cubed. So you're given the concentration of the H3O plus, and from that you know the equation of the pH is given by pH being equal to negative log concentration of HO3 plus, and you know what the concentration of the HO3 plus is, so you just substitute what the value of the concentration that you are given, and you will get the pH of solution A to be 3.84, because it's simple. When you're just given the concentration of the HO3 plus, you just substitute into the pH equation, and you calculate for your pH. And then B says calculate the pH of a solution with OH minus concentration being equal to 1.8 times 10 to the power negative 9 mole per dm cubed. Now the difference with B is that we are given the OH concentration, not the H3O plus concentration. But if you remember, we discussed the ionization of water, which is Kw being equal to the concentration of H3O plus multiplied by the concentration of the OH minus, equal to 1 times 10 to the power negative 4. So this is the value of the K ionization of water, which is the Kw. And from this equation, you can be able to calculate what the concentration of H3O plus is. So why are we calculating the concentration of the HO3 plus? Because remember, your pH equation, it requires the concentration of H3O plus, not of OH. So we can use this. We just equal this to 1 times 10 to the power negative 14, and you make the concentration of the H3O plus the subject of the formula, which will be equal to 1 times 10 to the power negative 14 divided by 1.8 times 10 to the power 9, and you will get the concentration of the HO3 plus to be 5.6 times 10 to the power negative 6 mole per dm cubed. And from here you go to your pH equation. You know what your concentration of the HO3 plus is, and you just substitute that concentration, and you will get your pH to be 5.25. Any questions, guys? You see how easy it is when you are given the concentration of the ions or the other one. It's easier for you to calculate what the pH is. So I remember when I introduced the log, everyone was so confused or intimidated by the log, but it's actually the simplest calculations. Any questions? If there's no question, let's move on to chemical equilibrium revision. In this question, the dissociation of acetic acid, is acetic acid a strong acid or a weak acid? Is acetic acid a strong acid or a weak acid, guys? Yes, it is a weak acid. So acetic acid is a weak acid. So the dissociation of acetic acid has an equilibrium constant at 25 degrees of 1.8 times 10 to the power negative 5. The reaction is, remember with dissociation, we discussed that dissociation is when that compound or that acid or base it dissociate into its constituent ions. So in this case, acetic acid undergoes dissociation, so hence it will become into its ions, like you have your CH3COO minus plus your H plus. If the equilibrium concentration of acetic acid is 0.46 moles in 0.500 liters of water, and that of CH3COO minus is 8.1 times 10 to the power negative 3 moles in the same 0.500 liters. Calculate the concentration of the reaction. So from what we are given what the equilibrium constant of the acid is, which is 1 times 8 times 10 to the power negative 5. And for the concentration of the product and the reactants, we are given the number of moles. So the number of moles of acetic acid is 0.46 and the volume is 0.5 liters. The same as the CH3COO minus. We're given the number of moles to be 8.1 times 10 to the power negative 3, and we are given the volume to be the same as that of acetic acid. So we can be able to calculate the concentration of acetic acid and the concentration of the CH3COO minus, and the concentration will be given by C equals to the number of moles divided by the volume. And the first step to do is to write your equilibrium constant expression. And remember, your equilibrium constant is equals to the concentration of the product divided by the concentration of the reactant. And in this case, our expression is going to be in this way. And the next step will be to substitute what we have been given. Remember, with the concentration of the CH3COO minus, we are given the number of moles and the volume. Hence, I wrote this bracket to show this is how you can calculate the concentration of the CH3COO minus multiplied by the concentration of the H plus, divide by the same with the acetic acid and the reactants. We are given the number of moles and the volume. So you just substitute your number of moles and the volume, because that will give you concentration from this equation. And you can substitute or you can do it separately as much as you calculate for what the concentration is. And from there, you just make the concentration of the H plus the subject of the formula. And what you're going to get to be the concentration of the H plus is going to be 1 times 10 to the power negative 3 molar. Do you understand, guys? Okay, now let's move on to the next question. This is still an equilibrium question as well. It says ammonia undergoes hydrolysis according to the following reaction. Ammonia reacts with water and it forms the NH4 plus ion plus OH minus. And the question says calculate the concentration of ammonia, the concentration of the NH4 plus, and the concentration of the OH minus in a solution. In a solution, originally 0.200 molar of ammonia. So in this question, we have ammonia that reacts with water, which undergoes hydrolysis. And from what we're given, we're only given the initial number of moles of ammonia. And what we're going to do is to go back to our table. You write your balanced chemical equation. That's the first step. Make sure that your equation is balanced. The first row is your mole ratio, and the mole ratio of this reaction is going to be 1:1:1:1. You have your initial number of moles, you have your changed number of moles, you have your equilibrium number of moles, and you have the concentration of the reactant and the product. Now, I have a question for you guys. Why, as you can see, we have been given the initial number of moles of ammonia at 0.2. But why are we not given anything for water? What could be the reason? Why are we not given anything for water? What do you think is the reason? Looking at the chemical equation, what do you think water will not given anything? Especially the initial number of moles of water. I don't know. Okay. So the reason we're not given anything for water is because in the chemical equation, the balanced chemical equation, water is liquid. And remember, while we do this calculation, we are dealing with equilibrium constant. And for your equilibrium constant expression, you cannot include your liquid phase. As you can see, ammonia is aqueous, water is liquid, the ions are in aqueous, hence we're not including water even on the table. So I just put it so you guys can see that you cannot use water. The same when we go to our equilibrium constant expression. You cannot include water in your reactant. Why? Because it is in a liquid form. Do you see it, guys? Okay, so that's the reason why I didn't put anything on. You're not even given anything for water. So we start with the initial number of moles of ammonia. And you know the initial of the reactants we're given to be that for ammonia, and the product is going to be 0 because the product has not been formed yet. And the change in this case is going to be negative for ammonia since it's our reactant, and it's going to be positive for our product. Why is it negative? It's because during the change, the number of moles of the reactants, they are being used up to form the product, hence the product is positive. For the change number of moles, it means that in this step or in this phase of the chemical reaction, there is more of the product than there is of the reactant, since it's been used up to form the product. And in this case, we are not given like in some other questions we've done before, where you were given that there is 0.7 moles after the left of ammonia when the equilibrium has reached equilibrium. So in this case, we're only given the number of. So what you're going to do for the equilibrium number of moles, which is this step, you're going to say 0.200 minus x. It will give you the equilibrium number of moles. The same as the product, you're going to say 0 plus x, it will be x. And for OH minus, it will be 0 plus x, it will be x. Now from here, we want to calculate the concentration of ammonia, NH4 plus and OH minus. What do? We write our equilibrium constant expression, and from the equation, remember your equilibrium constant is equals to the concentration of the products divided by the concentration of the reactants. And we're not including water because it's in liquid form, hence for the reactants you only have ammonia. You are given what the equilibrium constant is. It's 1.8 times 10 to the power negative 5. And from our table, the concentration of ammonia and OH minus, we don't know, so we're going to take it as x for the NHO4 plus and 0.2 minus x for ammonia, and you substitute that as the concentration on your Ka expression. And from here, you know x times x is going to be x squared, and you will still have your 0.2 minus x. And from here, you take this bracket 0.2 minus x to the other side of the equation, and you will be left with this. And when you take everything to one side and you multiply this inside, you will have your equation to be x squared plus 1.8 times 10 to the power minus 5x minus 3.6 times 10 to the power minus 6. As you can see, this is a quadratic formula, and for you to solve this formula, you can factorize, or you can use the quadratic formula. I didn't show that step because it will take more time, but x, the value of x that you're going to get is going to be 0.018. Are we together, guys? And since now we've calculated for x, we can go back to our concentration in the table. We know that the concentration of OH minus is x, so you just substitute your value of x. The same with NH4 plus, it's x, so that concentration and that concentration is the same. And for ammonia, since it was 0.200, you minus by the x you just calculated, and the concentration of ammonia will be 0.182. So in this table, on questions like this, sometimes they can ask you to calculate the concentrations, and this is how you do it. I hope you guys understand, and you will be able to solve this type of questions. how many marks? This might come with, if it's like this, if not 10 to 12 marks, or 11 if possible. So I think the highest will be 10 marks. Yeah, 10. Because there's a lot going on, from you writing the balanced chemical equation, filling the table, solving the equation, substituting, solving for x, getting the correct answer, getting the concentration of the three values. So it has more marks. That, yes, I know, by looking at what you have to do. Now, before we go, I want us to do an example just to refresh you guys' mind about the rate of reaction. It says consider the reaction. You have H2 plus I2 equals to 2 hydrogen iodide, and the enthalpy change is less than 0. Is this reaction exothermic or endothermic? And you know, when the enthalpy change is less than 0, the reaction is exothermic, and when the enthalpy change is greater than 0, it is endothermic. And the reason is the enthalpy change is less than 0, because that's why the reaction is exothermic. And 3 says, how does energy of the product compare to that of the reactants? If you remember from the endothermic and exothermic graphs we did, we mentioned that the energy of the product is less than the energy of the reactant when the reaction is endothermic, and it's opposite when it's endothermic. It means that the energy of the product will be greater than the reactant of the energy of the reactant if it's endothermic, but when it's exothermic, the energy of the product is less than the energy of the product. So that's it from me with the revision of chemistry, guys. Any questions? Any questions, guys? Okay, if you guys don't have any questions, I think we'll end our lesson here today, and I will see you guys in our next class, and we'll be doing the physics revision, which is on Thursday. So bye everyone, have a great day further.